Hello, this video is going to go over the AP Statistics Exam Review number 3, multiple choice questions. There are 12 items in this one, so it's a bit longer than the last one, but not quite the length of the first one. Here we go, question number 1. Let's read the question. A bank surveyed all of its 60 employees to determine the proportion who participate in volunteer activities. Which of the following statements is true? A, the bank should not use the data from the survey because this is an observational study. B, the bank can use the result of this survey to prove that working for the bank causes employees to participate in volunteer activities. C, the bank did not select a random sample of employees, so the survey will not provide the bank with useful information. D, the bank would not have to use the survey, the bank would have to use the survey data to construct a confidence interval in order to estimate the proportion of employees who participate in volunteer activities. Or E, the bank does not need to use an inference procedure to determine the proportion of employees who participate in volunteer activities because the survey was a census of all employees. So think about this, try this on your own. Pause it if you need to and try to answer that. The correct answer for this one is E. Look very carefully at the wording of the question. A bank surveyed all of its 60 employees, which means that they have all the data. They have the parameter. They don't have to estimate anything. They have the parameter. They have all the data. They know every single answer. So which of the following statements is true? The bank does not need to use an inference procedure to determine the proportion of employees who participate in volunteer activities because the survey was a census of all employees. And a census, don't think of the census as the people that come around and ask for your demographics every 10 years. A census in general is when the population you're seeking, you ask everybody in that population. That's what a census is. And in this case, the population was all 60 employees at the bank. Question number 2. A compact disc CD, we all listen to those now, manufacturer wanted to determine which of 2 different cover designs for a newly released CD will generate more sales. The manufacturer chose 70 stores to sell the CD. 35 of these stores were randomly assigned to sell CDs with one of the cover designs, and the other 35 were assigned to sell the CDs with the other cover design. The manufacturer recorded the number of CDs sold at each of the stores and found a significant difference between the mean number of CDs sold for the 2 cover designs. Which of the following gives the conclusion that should be made based on the results and provides the best explanation for the conclusion? So let's not worry about these right now. Let's just think about what's going on. This was an experiment. How do we know? They have different treatments. Okay, the treatments was, hey, we're going to randomly assign 35 stores to sell CDs of one cover design, and the other 35 are going to get the other cover design. Then we're going to compare the results and see which one, gets the best sales, I guess. So in an experiment, you can determine cause and effect. All right, you can say, hey, one thing causes the other if you have the data to prove it from the experiment. All right, so with that in mind, let's go through these answer choices. Letter A, it is not reasonable to conclude that the difference in sales was caused by the different cover designs because this was not an experiment. Well, that goes against what we just said, right? It was an experiment. Letter B, it is not reasonable to conclude that the difference in sales was caused by the different cover designs because there was no control group for comparison. Well, you don't need a control group in this case because you have the 2 different cover designs, right? One, these are all randomly assigned, and where you're either going to have one cover design or the other cover design, and you're going to compare those differences. So control is not needed. Control is needed when you might have like one new medicine, for example, or one new treatment, and you want to have like a placebo or maybe the old treatment or something to compare it to. Okay, that's a control group. We don't need control group in this situation. Letter C, it is not reasonable to conclude that the difference in sales was caused by the different cover designs because the 70 stores were not randomly chosen. All right, it's not about the stores being randomly chosen. It is about random assignment, and we do have random assignment. The randomness comes from the random assignment to see which stores got which cover design. So random assignment is what allows us to be able to have good data. Letter D. It is reasonable to conclude that the difference in sales was caused by the different cover designs because the cover designs were randomly assigned to stores. And that, my friends, is what we're looking for. We have that random assignment here. Stores were randomly assigned. And the other 35 were assigned to sell the CDs. Well, even though the other 35 weren't randomly assigned, we got the randomness from the first 35, so we already have those mixed up. And letter E, it is reasonable to conclude that the difference in sales was caused by the different cover designs because the sample size was large. That's not what determines the cause and effect, okay? The random assignment, okay, that helps determine. The large sample size might give you better data, but it's not gonna help you draw those conclusions from cause and effect. So the answer choice is D. Question number 3. The manager of a public swimming pool wants to compare the effectiveness of 2 laundry detergents, detergent A and detergent B, in cleaning the towels that are used daily. As each dirty towel is turned in, it is placed into the only washing machine on the premises. When the washing machine contains 20 towels, the manager flips a coin to determine whether detergent A or detergent B will be used for that load. The cleanliness of the load of towels is rated on a scale of 1 to 10 by a person who does not know which detergent was used. So that's kind of like a blind experiment, which is what we want. And then the coin flips give you the randomness. The manager continues this experiment for many days. Which of the following best describes the manager's study? A, a completely randomized design. B, a randomized block design with detergent A and detergent B as blocks. C, a randomized block design with a washing machine as the block. D, a matched pairs design with detergent A and detergent B as the pair. Or E, an observational study. Pause the video for a minute if you need to look up those terms while you're trying to answer that question. Go for it. Okay, the answer to this question is A. So what makes it a completely random design? A completely randomized design. First thing you want to look for is there 2 or more different, subjects or treatments being imposed in a comparison without any extra groups being formed? If that's the case, that's a completely randomized design. And how do we know this in this case? Well, let's look at the output of this. All right, in this experiment, we have 2 laundry detergents, detergent A and detergent B, in cleaning the towels that are used daily. As each towel is turned in, it's placed in the only washing machine on the premises. 1 washing machine, right? So we're not comparing washing machines. We have 1 washing machine, and it's either going to have detergent A or detergent B. So the washing machine contains 20 towels. Manager flips the coin to determine whether detergent A or detergent B will be used for that load. So the load of 20 towels represents your subject, okay? Each, not 1 towel, but like a load of 20 towels. Is your subject. Does that make sense? Okay, we're not going to watch 1 towel at a time. The randomness comes from that coin flip, right? So it's either going to get detergent A or detergent B randomly, and they continue to experiment for many days. So it doesn't say how many specific times they're using it, but you can rest assured that since there's randomness to whichever load is going to get detergent A or detergent B, this is just a completely randomized design. Okay, it's gonna have basically the detergent. It's gonna have detergent A, detergent B, and think about the load. It's gonna have one of those 2 things, and then what's gonna happen is you're gonna compare the results. What is the other information? A randomized block design with detergent A, detergent B as blocks. Blocks are you can look that up if you'd like. I did that already. So a block design is when there are different groups that might have different outcomes. So for example, let's say you had multiple washing machines in this experiment, and maybe one washing machine does a better job than the other, right? So you might want to block off the experiment in washing machines and then do each type of detergent per washing machine and compare the results. That way, maybe one washing machine, if it you know it does better, you can compare the results within each washing machine and see which detergent is more effective. So that's a way to do block design. But since we only have one washing machine, no real reason to do a block here. And you can't really do a matched pairs in this one, right? Because you can't like wash the towels and then right afterwards wash them in a different detergent and compare, because they're going to be clean. You know what I mean? So it's going to screw up the results. And it's definitely not an observational study because we are doing an experiment. Okay, this is an experiment. All of these are experiment. This is just looking at data. So we can rule that one out. So that's a completely randomized design. Question 4. In the design of a survey, which of the following best explains how to minimize response bias? Increase the sample size, decrease the sample size, randomly select the sample, increase the number of questions in the survey, carefully word and field test survey questions. Go ahead and think about pausing this question, look up your terms if you need to. Now, if you looked up response bias, you might notice that it says, if you flip back on the notes, it says the response bias is when students provide when respondents provide incorrect answers. So response bias is incorrect answers provided. Why might they do that? You know, you might think about like, well, you might have a question that's worded, do you use drugs, for example? If they're illegal, and maybe somebody doesn't want to answer that they use drugs because of the repercussions, because they don't know what's going to happen. So the wording of the question can result in response bias. So the best way to minimize response bias is actually in the question itself. The sample size and randomness help deal with getting better results, but as far as the responses itself, you want to carefully word and field test those questions, carefully worded questions. Okay, if you have more bad questions, that's not going to help with your response bias. And if you have more in your sample size, but you have badly worded questions, you're still going to get that response bias. So it's going to be E. Carefully word those questions. Question number 5. A polling firm is interested in surveying a representative sample of registered voters in the United States. The firm has automated its sampling so that random phone numbers within the United States are called. Each time a number is called, the procedure is as follows. There is no response, or if an answer machine is reached, another number is automatically called. If a person answers, a survey worker verifies that the person is at least 18 years of age. If a person is not at least 18 years of age, no response is recorded and another number is called. If the person is at least 18 years of age, that person is surveyed. So those are the 4 steps they use for that. Some people claim the procedure being used does not permit the results to be extended to all registered voters. Which of the following is not a legitimate concern about the procedure being used? So what's not a concern about our procedure being used? So let's look at all, first of all, careful with those questions, because you might think about which is a concern, which is not a concern. What are we not worried about in this case? So let's look at our answer choices. Registered voters with children under the age of 18 may be underrepresented in the sample. Now, if I'm looking at this and you got a machine randomly selecting numbers to call, I would say you probably would have this as a valid concern, right? Because registered voters with children under the age of 18, you know, might pick up the phone, might call if you've got a landline or home phone. So that is definitely a concern. B, registered voters with unlisted phone numbers may be underrepresented in the sample. Registered voters with unlisted phone numbers or telephone numbers may be underrepresented in the sample. Well, let's think about this for a second. Registered voters with unlisted phone numbers. So just imagine, like, you have a directory of numbers, and is there a person or some machine looking through that directory to get those numbers? No. What's happening? It's an automated. It has automated sampling, so random phone numbers within the United States are called. There is no listed numbers being called. It's just a random set of digits that maybe they get a number, maybe they don't. So that's not a concern, right? Because unlisted phone numbers, it doesn't matter. They're random. So that's going to include the unlisted phone numbers. So those aren't underrepresented. That's going to be your answer. But let's look at the other wrong answers so we can just kind of read through them. It's always good to read every single answer choice if you have the time. Registered voters who have more than one telephone number may be overrepresented in this sample. That is true, because if you have let's say you have a home phone and a cell phone, and both get in the pool, you could potentially be called twice. So that is true. That is a concern. D, registered voters who live in households consisting of more than one voter may be underrepresented. Registered voters who live in households consisting of one or more than one voter may be underrepresented. That is also true. It might kind of balance this one out, but that is also true, because if you have, like a mom and dad at the home and they call that one number, that home phone, only one person's going to answer the phone and answer the questions. So that's a concern. It's not a legitimate concern. And letter E, people who are not registered to vote may bias the sample results. Sure, there's a lot of people that aren't registered to vote and they're still getting called, right? So that is absolutely true, right? Because you might have different opinions from registered voters than you do non-registered voters. So the only non-concern is this one, just because the unlisted phone numbers isn't a concern. There's randomness to your automation process. Number 6, a school principal wanted to investigate student opinions about the food served in the school cafeteria. Ugh. The principal selected at random samples of 50 first-year students, 50 second-year students, 50 third-year students, and 50 fourth-year students to complete a questionnaire. Which of the following best describes the principal's sampling plan? Well, if you need to look up these different samples, take a minute to pause. So we have kind of 5 different types of samples: stratified, simple, cluster, convenience, and systematic. One of the ones that I want to always look for that we can rule out is things like convenience or convenience sample or voluntary response samples. A lot of times, if you look at this question here, the way it's worded, they're not going to be those, because convenience is, you go up to people on the street, ask them questions or whatever. They're right there. Voluntary responses, you do a questionnaire, you get people to respond back in. But in this case here, they're very specific: 51st year, 52nd year, 53rd year, 54th year, freshmen, sophomores, juniors, and seniors. And they made sure to ask each different grade level. And they did that because they wanted to have better results, right? A stratified random sample, that's when you have, let me kind of define stratified here. That's when you have different groups and they're all homogeneous, right? So they all might be group A, B, C, D. Group A might have similar characteristics within there, so they're grouped together. Group B, Group C, Group D. And in terms of grade level, that might be one way to group them, right? Maybe seniors have a different take on the food served in the school cafeteria than freshmen who don't have a refined palate like you guys do. So that would be considered a stratified sample. And in fact, that's what the answer to this question is. It's a stratified random sample. And stratified random samples, you have homogeneous groups. Of similar characteristics. I can go over the other ones as well real quickly. A simple random sample is when everybody's mixed up into the pot. So if you wanted to do a sample of 200 students, all people in that school would be in the sample pool and you'd randomly select those. So that's not the case here, because we call that a SRS, by the way, to distinguish from a stratified. A cluster sample is that's what it looks like when you have different groups, but those groups might be heterogeneous. They might have a lot of different mixtures into them. So a cluster sample, what you're doing is you're picking heterogeneous groups. So it might look like you might have a few, we'll just do colors to make it easy, but maybe you have a few freshmen, a few sophomores, a few juniors and a few seniors in each group, and you randomly pick one or two of those samples. That's a cluster sample, okay? So cluster is hetero, meaning different, okay? So there's a bunch of different groups in there. So that's not the case here. And a systematic sample would be like, you're going and maybe you have a list of students alphabetically and you're picking every 5th student, or however you decide to break it down. But systematic is more like a pattern, and that's clearly not the case here. So a lot of people, if they get these confused, stratified versus cluster. Stratified is homogeneous, where you have different groups, but they're all you want to make sure you select all of those groups, do a random sample within each of those groups to get better data. Okay, a cluster is when you group your school or whatever into heterogeneous groups that have a mixture of different people, and you randomly sample one or maybe a couple of the clusters. This is stratified. Question 7. An experiment will be conducted to determine whether children learn their multiplication facts better by practicing with flashcards or by practicing on a computer. Children who volunteer for the experiment will be randomly assigned to one of the two treatments. Because of the children's gender may affect the outcome, there will be blocking by gender. After practice, the children will be given a test on their multiplication facts. Why will it be impossible to conduct a double-blind experiment? A double-blind experiment is when the person or group of people conducting the experiment and the subjects have no idea what treatment's being imposed on what. So it's possible that the person running the experiment has no idea which students get what treatment. However, do the students know what treatment they're getting? Think about that and answer the question. All right, let's look at our answer choices. A, the experimenter will know whether the child is a boy or girl and whether he or she used flashcards on the computer. That's not necessarily true, because it could just be volunteers, they could just be randomly assigned. So the experimenter isn't necessarily in the know of that. B, the child will know whether he or she is a boy or a girl. Well, I hope so. However, that has nothing to do with the double blindness of it, okay? The child will know whether he or she used flashcards. They're the one doing it, right? If they're looking at a computer screen, it's pretty obvious they're using the computer. They're using flashcards, it's pretty obvious, right? The child's going to know. So the child it can't be double blind. It can mostly be single blind from the experimenter's point of view. The person who grades the test will know whether the child was a boy or girl. Not necessarily. The person who grades the test will know whether the child used flashcards on the computer. Again, not necessarily. But what we do know is the child will know whether he or she used flashcards or the computer. Number 8, a recent study examined 699 car accidents in Toronto over a 14-month period. Records of phone service providers were used to determine whether the driver was using a cell phone during or immediately before the accident. Overall, the researchers found that drivers using cell phones were 4.3 times as likely to have an accident as drivers who were not using cell phones. The result was statistically significant. Which of the following can be concluded in the study? So what happened? We looked at data. We looked at the records. We found results to be statistically significant. One question you have to ask is, was this an observational study or was this an experiment? Pause the video to see if you can figure this out. Okay, guys. So let's take a look here. A, cell phone use increases the likelihood of a car accident. Was an experiment performed? In that case, no, we're not going to give drivers cell phones and say, all right, go drive, see what happens. We don't know that. B, there is an association between cell phone use and accidents, but not necessarily a causal relationship. So we've linked that there is some relationship between those two, but we haven't determined if there's a cause and effect because, again, no experiment. So that is actually true. There's a correlation between cell phone use and accidents, but not necessarily as there should be an association. Well, we've determined that there is an association, okay? So that association in more general, a relationship. That's a better word in this case than correlation. Correlation is a very specific, like, that's that R value there. And we haven't necessarily computed that or have looked at that, and there very well could be, but there's definitely an association between those two. So we're gonna say B is the better option in that wording. D, the association between cell phone use and accidents is negative. Well, it appears in this data that it's positive, right? Because the more people that were shown to use cell phones were in accidents. So that one increases the other, or one increase as matched up with another increase. So that's false because that should be positive. And then E, cell phone use causes more accidents in Canada, but not necessarily in the United States. Again, we have not determined causal relationship. So anytime you see that word cause, but no experiments performed, you can rule that out. I want to refer to you to here's a diagram here to kind of help you remember things. If it's an experiment, okay, where there's random assignment, then you can determine cause and effect. If there's no random assignment, you cannot determine cause and effect. So you see, nobody's randomly assigned to use cell phones or not. So it's not a causal relationship. There was no random sampling either. So there's really no generalization other than you can just say, hey, there's some sort of relationship. Okay, we can't compare it to everybody outside of a certain area, but we can say there is a relationship, but we can't generalize it or determine cause and effect in this scenario. Number 9, a regional transportation authority is interested in estimating the mean number of minutes working adults in the region spend commuting to work on a typical day. A random sample of working adults will be selected from each of 3 strata: urban, suburban, and rural. Selected individuals will be asked the number of minutes they spend commuting to work on a typical day. Why is stratification used in this situation? Stratification, meaning that we stratified random sample, in this case, the urban, suburban, and rural would be the different strata. And stratified random sample, meaning that, drivers in urban areas are going to have different commute times than suburban and rural, right? That's just the fact. So we want to make sure that we have enough of each of those to be used. What does that do? Well, it doesn't do anything with the bias because it's in hopes that we have a random sample. We already have randomness, right? So there is no bias needing to be removed because our random sampling already takes care of that. Well, it doesn't completely remove bias, but it reduces bias. To decrease the variability in estimates of the proportion of working adults living in urban, suburban, and rural areas. Let's read that again. To decrease the variability in estimates of the proportion of working adults living in urban, suburban, and rural areas. Now, what does this question want to know? It's interested in estimating the mean number of minutes working adults in the region spend commuting on a typical day. It doesn't specifically say what specific area, right? It just says a region. So they kind of take that overall region and find the urban areas, suburban areas, and rural areas and do some random sampling within each one in hopes that we can have some sort of combined data that ultimately leads us to this, to decrease the variability in estimates of the mean commuting time, because that's what we were talking about right there. So the answer to that is E. The stratification's goal is to decrease variability. That's why we do stratified samples. That's why we do cluster samples. Systematic samples is to have less variability in our data. All right, you can do a simple random sample, but you might urban, suburban, or rural might be overrepresented. So you want to stratify that in this case so you can have a little bit of each one. Those are good measures to reduce variability. Question 10, a randomized block design will be used in an experiment to compare two lotions that protect people from getting sunburned. Which of the following should guide the formation of the blocks? Look up blocks if you need to. What's the purpose of blocks? Blocks are groups of people that have similar characteristics. So in this problem here, think about what would be a good way to block people using sunblock. Sunblock. You have very pale skinned people or maybe darker complexions. They're going to have different reactions to the sun, and the lotions might also impact how they react to those. So when we're doing the blocks, you want to think about getting people with similar characteristics in those blocks. They're going to know where they are, right? You have a bunch of really pale people in a block. They're going to know that they're being compared with those people. So we're trying to compare two lotions. The lotions themselves are the treatments. So if you're doing a treatment, those treatments cannot be the block. All right, those are not the same, because the idea here is that you might have different people with different complexion in different groups, different blocks, and then you can compare the different lotions within each block to see which one's more effective at reducing sunburn. So participants in the same block should receive the same lotion. No, we don't want that. We still want to compare the lotions. B, participants should be randomly assigned to the blocks. That defeats the whole purpose of the blocks. A block, it gets people with similar characteristics. So I wanted to kind of refer to that again. Those have to be kind of weeded out first. C, participants should be kept blind as to which block they are in. No. D, participants within each block should be as similar as possible with respect to how easily they get sunburned. That's the one that we want, right? Blocks give you similar characteristics so they can compare results within those blocks. And letter E, participants within each block should be as different as possible with respect to how easily they get sunburned. That goes against the whole notion of blocks, right? You want to have people with similar, not different. So we need similar. So D is going to be your answer. Number 11, there were 5,317 previously owned homes sold in a Western city in the year 2000. The distribution of the sales prices of these homes was strongly right skewed with a mean of $206,274 and a standard deviation of $37,881,000. If all possible simple random samples of size 100 are drawn from this population and the mean is computed for each of these samples, which of the following describes the sampling distribution of the sample mean? Remember that a sampling distribution is all possible random samples of a certain size. So in this case, we have a sampling distribution of all possible samples of size 100. Now, let's talk about that size first. when you're doing means, you know, the important thing for a sampling distribution is one of the things that we talked about before was the central limit theorem. If you have a sample size of at least 30, then your sampling distribution can be approximately normal. All right, smaller sample size, you're not going to have a normal distribution if it's right skewed. Your sampling distribution would be right skewed. However, since we have at least 30 in our sample size, it's actually going to make our sampling distribution approximately normal. Remember, a sampling distribution is basically a bunch of sample means. And the goal is to estimate the true parameter, right? So that in an ideal situation, when you have a sampling distribution, all these bunch of sample means, when you have a large size, especially like 100 or even less than 100, you're going to get a distribution if you have every possible sample that's going to look, you know, bell-shaped. It's going to look normal. What's the center of that? Well, the mean ends up being the population mean. So the population mean in this case, it says a mean mu of 206,274. That's going to be the mean of your sampling distribution. Do we have a formula on our formula sheet that tells us about it? Yes. If you go to your formula sheet, if you look on that second page where it talks about sampling distributions for mean, you can see that the mean of all the individual samples is equal to the population mean. Now we'll come back to that other formula in a little bit. So the mean of the sampling distribution, we do that mu with the little x bar, is equal to the population mean. So that's why we have 206,274 for all your means. However, since it's at least 30 in our sample size, we can get the right skewed out of there. We know it's going to be approximately normal because n is greater than or equal to 30. So now let's figure out that standard deviation. Well, we actually have a formula for standard deviation for standard sampling distributions. And right next to that mean, you'll notice that it's the population standard deviation divided by the square root of n. So your sampling distribution standard deviation is the population standard deviation divided by the square root of the sample size. So we're talking 37,881 divided by the square root of 100. So if you want to take a minute to calculate that number, it'll tell you which one of those it is. Square root of 100 is 10, so you're really just dividing by 10, move the decimal over once. The answer should be about 3788. So 3,788 is your standard deviation of that sampling distribution, so it's going to be A. All right, this last question is very similar to the one prior to it. So let's look at it. Let X be a random variable that has a skewed distribution with a mean of mu equals 10 and a standard deviation of 10. Based on random samples of size 400, so n is 400, large sample, the sampling distribution of X bar is, well, we have a large sample size, so we know that's going to be approximately normal. So let's get rid of these skewedness right there. We can get rid of A, B, and C. So I want you to basically do what we did in the previous problem. Find out what that standard deviation is based off the sample size. All right, the mean of the sampling distribution is the population mean. So we know that's 10. The standard deviation of the sampling distribution is the population standard deviation divided by the square root of n. So that's 10 divided by the square root of 400. Square root of 400 is 20, so 10 over 20, or you can use your calculator, is 0.5. All right, guys, thank you for watching. I appreciate you being consistent with your review. You guys are doing great. Keep up the good work.